Hello everyone. I'm really excited to be back to discuss about one of the interesting feature in MLflow, which is MLflow dataset tracking. Yes, you don't need any external tool anymore to track different versions of your data. You can do it within MLflow itself. For people who are new to dataset tracking, let's try to understand why dataset tracking is needed with a simple example. We have an end-to-end workflow which has been divided into 3 different phases. So the first phase is the data curation phase, where we are going to collect some samples which are relevant to our topic. And for this, we have a huge data set, which is a Wikipedia data set. The data size is more than 40 GB and it contains more than 6 million English articles. As the first step, we are going to perform a keyword-based search to filter a couple of articles which matches our keywords. Once we have the search results, we are going to refine it further using LLM. Once we have the curated data set, we are going to move to the phase 2, where we are going to prepare this data set for evaluation. Imagine you want to perform natural language task on top of these articles. You need to prepare these articles and send it to LLM. And that is the second phase, where we will be preparing the evaluation data set. Once the data set is ready, the third phase will be the actual evaluation phase, where you'll pass on these articles to an LLM and get the results annotated. If you look at this pipeline, the data as such evolves over a period of time. When we started with the data set, it was a huge data set, and then we refined it using LLM. And we are preparing it for the evaluation. At the end, we have the annotated data set as such. If you miss to track different versions of the data, not be able to reproduce these results later, as each step has an LLM action where when you try to change the prompt, when you try to run it multiple times, the results might change. And in turn, the metrics will change. And another reason to have this dataset tracking is that you don't need to load this huge dataset over and over, which is going to consume a lot of memory for you. Okay. I hope it is clear that dataset tracking is much needed. Now let's go ahead and look into the implementation part. Before we start running the code, there are two important prerequisites. The first one is to make sure that you have your MLflow server up and running. And when you're starting your MLflow server, make sure to have the backend store URI set. In this case, I'm starting with the SQLite database, which is in my local folder. And once that is done, you can launch your MLflow UI in localhost 5000. And the second step is to copy your LLM keys to .env file. Now let's go ahead and run the imports. For this particular example, I'm using LangChain framework for the LLM orchestration. Our MLflow server is running in localhost 5000, and I have set up this experiment name to be dataset tracking example. Let's go ahead and load the Wikipedia dataset. So as I said, the dataset as such is really huge. It's over 40 gigs. So make sure you have enough memory to download this dataset and load it. One good part about high-phase dataset is that once you have downloaded this dataset and loaded it once, it always loads it from cache. So if you have done it already, it doesn't take time to load this dataset. Okay, we have the dataset loaded already. It has more than 6 million articles, and the next step is to perform a keyword-based search. So here we're going to extract the articles which are relevant to the keyword artificial intelligence. We are going to search all 6 million articles and see if any of these articles has this keyword appearing more than thrice. The keyword artificial intelligence more than 3 times, then we are going to filter those articles as such. At the end of the filtration, we have more than 1,600 articles selected here. But in order to identify the articles which are much more closer to this particular topic, we are going to perform one more refinement using an LLM. In this case, you can choose either OpenAI or Google. I'm choosing OpenAI. And what we're going to do is to pass in the ID and the title of these articles, these 1,683 articles, to an LLM, and then prompt the LLM to return the top 100 articles which matches this keyword. So here I have created a simple prompt. You are provided with this ID and title of the Wikipedia articles. Identify the top 100 articles which best matches to this particular topic. So the expectation at the end of this particular step is to extract the articles which are much more closer to this particular topic. Let's wait till the predictions are printed. Now we have the output from the LLM. It has returned the list of articles, 100 article IDs, which matches the closest with the keyword artificial intelligence. So let's run a simple post-processing step to extract these numbers and then filter these articles from the dump of 1,683 articles which we had it in the previous step. Now here we have the top 10 articles, and you can see that these articles are much more relevant to the keyword artificial intelligence. Before we move on to the next phase of data preparation, it is important to version this particular data set. Why? Because we are using an LLM to extract, to identify the articles which are much more closest to the keyword. And there is no guarantee that when you're going to rerun this experiment, you'll be getting the same IDs. And to um, extend this particular search with, say, 200 or 300 articles as such, or you want to refine the prompt to make the selection much more better, eventually the end metric that you have is going to change. And it is important for us to track this particular data set. Dataset tracking in MLflow is very easy to perform. All you have to do is to use MLflow.data. This utility already supports multiple types of datasets. You can use pandas, you can use Spark, the Hugging Face dataset, NumPy dataset, and multiple different dataset combinations and such. So here I'm loading a dataset from the pandas data frame, as we already have it in the pandas format, but you can check out the documentation for other dataset types as well. And we can pass in a couple of other parameters, and here I'm passing the dataset and the dataset name as such. And then to log the dataset, you can start a new run and log the dataset as the input itself. It's plain and simple. Let's go ahead and log this dataset. Okay, we have the dataset. Let's move to the MLflow UI and go to the experiments. Okay, here we have the experiments. Click on dataset tracking example. As we see, we have the log dataset, the top 100 artificial intelligence articles, and it has automatically logged the schema of this particular dataset. You can use this dataset ID. Imagine you're working on a team and you want to share this dataset. You can, always query this dataset using dataset ID. You can use, pass on this dataset to one of your teammates and, continue with the experiments. Now that we have logged this raw dataset, let's try to move on to the next phase. One cool thing about MLflow dataset is that you can just log your raw data with as many columns as you want, and MLflow automatically captures the schema and maintains it. And before we move on to the next step, where we want to perform, say, a summarization task on these 100 samples which we have curated, we have to prepare the data. And for that, we are going to convert this data set into the MLflow format, where we want to have every single row with the inputs and the expectations. So the inputs are the actual articles. Expectations is going to be the ground truth. At this point of time, we don't have the ground truth information, and hence I'm leaving the expectations tag empty. Before we move on to the actual evaluation part, we can log this evaluation dataset as well. And to log the evaluation dataset, we can use the utility from GenAI library, which is create dataset. So create dataset is the utility from mlflow.gna.datasets. And all you have to do is to invoke this create dataset method with the dataset name, and you can add your custom tags. For example, in this case, I'm adding the type as summary and the source as Wikipedia. And you can add as many tags as you want. Once you have this dataset initialized, you can add in the number of rows to this particular dataset. For example, let's add 10 rows to this example for this demo. And it is done. We can move to the MLflow UI. Let's switch to, say, GenAI and go to the datasets tab. And here we can see that we have logged the evaluation dataset, where we have the 10 different rows logged here. And we have the inputs, right? We don't have the expectations, which is the ground truth yet, but our dataset is ready for performing any kind of evaluation. You can perform all the CRUD operations on this particular dataset. You can use this method. If you have the dataset ID, you can pass in the dataset ID and query this dataset from MLflow server. And you can even perform a delete dataset, or even if you want, you can add a few more samples to this dataset using summary dataset.merge records. Now that we have the evaluation dataset ready, which is the phase 2, let's move on to the phase 3, where we run the actual evaluation. So we are going to perform the summarization task on top of this particular dataset. For that, I have created a simple predict function, which takes in the article. And here is the prompt to summarize this dataset with the important points. We are going to substitute the actual article into this prompt with the LLM call, get the response, and then return the content. Given an input article is going to return the summary of the article. And to perform the prediction, we're going to use the MLflow evaluate library. So MLflow GenA evaluate takes in three parameters. The first one is the data. As we already have the evaluation data set, we don't have to convert this into a data frame or any other format. We can directly pass in the summary data set. The second one is the predict function. So we have already created a predict function which performs the summarization. And third one is the scorers. Here you have multiple options. I'm using a predefined scorer which checks the safety of the response. Let's go ahead and run this GenA evaluate call. Now we have the evaluation results ready. Let's click on this. Okay, we are moving to the evaluations pane. Here we can see we have two different runs. So the first one is the one where we logged our data set, the raw data set. And now we have the second run. So this is the evaluation run where we try to summarize 10 articles. Here we can track the assessment scores, and each article we have the separate trace where we can look at the request, the prompt, the response, number of tokens, and all these informations are captured here. Now let's switch back to the code. Another way to track the result is that once the evaluation is over, the results are tracked in the results variable. You can track the results using results.resultdf, and it prints the result as a data frame with a lot of information here. Now, if we think through, when we started with the evaluation, we only had the inputs. We didn't have the ground truth as such. So at the end of this particular step, we have the output from an LLM. We can manually evaluate the output, make necessary changes, and we can use this data set as an input for further training, right? So that is the reason it makes sense to store this output as an annotated data set. In order to do that, we are going to use the same create dataset library, but now we are going to create another data set which is called annotated data set. And this, so I'm going to create a tag named annotated. Let's go ahead and create this empty. Right now it's going to be empty. The results to this, we want to merge the rows. In order to do that, I'm going to add the inputs. The inputs are going to be the original article, and the expectations now is the response that we received from LLM. And every row has an input and an expectation. And then let's go ahead and merge the records. Okay. Now, when we switch back to the MLflow UI and move to the data sets, we see that we have the annotated data set. We not only have the inputs, but we also have the expectations. The expectations are nothing but the result which we received from the LLM. In this case, we used the output from a single run. But imagine you had output spread over multiple runs. As such, you were trying to summarize articles based on multiple different keywords, then the results are going to spread across multiple runs. So there is an interesting way to search these runs and create an annotated data set on top of it. Let's go ahead and delete this data set. So you can use the delete data set utility from MLflow generate datasets to delete a dataset. All you have to do is to pass in the dataset ID. In order to search the traces across multiple runs, all you have to do is to use MLflow to search traces. And here you can limit the number of results that you want to search. And you can add the result type. You can search it based on one single run, and you can search it based on filters. Here I'm using the run ID as a parameter to search the, but you can pass in the filter string by which you will be able to identify multiple different runs. You can limit your search results. When I run this, it is going to retrieve 10 different traces which are mapped to this particular run ID. And then here are the 10 traces. And from the trace, I can derive the request and the input which we pass to the LLM and the response which we received from the LLM as a summarized text. Now that we have the input and the response, we can create the same annotated data set as the inputs and the expectations and use the same create data set to create the empty data set. And here we have the annotated data set from trace. Once we have the data set ready, we merge the records. Now let's go to the MLflow UI and refresh this pane. And here you can see that we have annotated data set from trace. And in this case, we created this data set by searching the trace and adding the relevant information. So the big takeaway from this is that at every single step, you see that your data set changes rapidly, especially when you're working with GenAI workflows. It is essential to have the reproducibility. And hence, MLflow makes this dataset tracking way simple by using MLflow GenAI datasets utility as such. I hope you found this demo useful. Do try it out with your own data set and let us know your questions in the comments. Thank you.